Hello everyone, welcome back to KSM 3413 Statistics 1. In this video, I'm going to share about estimation. So what is estimation? When you're conducting research, you are interested about a specific population. But in reality, you cannot get access to everybody in a particular population. You cannot gather information about everyone in a big population. So what we do is we try to get a representative, a sample from the population to make a conclusion about the bigger population. Just like when you go to a supermarket, people give you sample drinks, people give you sample food. Do they give you the entire box for you to drink and make a conclusion? No, you are given a small sample. So with that small sample, a small cup of drink, you can make an inference about the entire bottle. You can make the inference about the juice or the food that is being sold at the supermarket. So you decide whether you want to buy or not. So same applies in research and statistics. What we do is we do not take the entire population for a study. It can be costly, sometimes it is not even accessible. So what we do is we sample representative, a well represented sample from the population to make conclusions about the population. So what do? When we collect samples, when we take sample representative of the population, what we do is we ask them questions. We sometimes, let's say that you are interested in students CGPA or students grade cumulative point average. So you are interested for the entire university of UPSI, but you cannot go and get everybody's CGPA. So imagine that you don't have a database, okay? So if you want to get everybody's one, it's not feasible and you cannot reach everybody. So what can you do? You sample participants, you sample people from every faculty, a certain number from every faculty, so that you can have an average from all these people. What is the average of it? Average of CGPA, and that average can be used to make inferences about the entire UPSI students cumulative grade point average. Okay, so with a small sample, with a sample that very representative of your population, you can make conclusions. So that is what we mean by estimation. You are estimating what would be the true populations statistics or informations. Okay, so whatever that we measure at the sample level, such as mean, proportions, variance, and all these for a sample is called statistics. But whatever that the same information that you measure at a population level, it's called parameters. Okay, so you can still compute parameters, mean for a population, and you can also find the mean for a sample. Okay, so why do we need the estimation? Because you do not know about your population. As we say that we don't know anything, we don't know the average cumulative grade point or CGPA of the entire population. So what we are trying to do is we are trying to use the information from the sample to actually understand about our population. So there are two types of estimation. One is called point estimate, the other is interval estimate. So what is a point estimate? Point estimate meaning a single estimate, the exact value. Okay, so if you calculate a mean, variance, mode, everything is a single estimate, just one value. Okay, but we have to understand that we are sampling people from a larger population. So every time we sample different group of people, the tendency of getting different values are there. Okay, because it's impossible that you will always get the same sample. So samples, when samples differs, the statistics or the parameters statistics will change. So which is the true representative value for the population? Because we are interested in making conclusions about the population. So which of the sample mean is the true population mean? We don't know. We cannot also answer the question because unless you already know your population parameters or population mean. So when you sample it, you need to know which one is the accurate one. Okay, so point estimate has a drawback because it is subject to the samples. So what they suggest is, okay, rather than relying on a single value, we estimate a range of values. Okay, so rather than saying that, okay, a grade point average for this sample is 2.5, we tell them that, okay, this might change from different samples. So interval estimate says that, okay, rather than saying 2.5, okay, it is a range between 2.2 and 2.5, for example. So you give them a range. So within this range, any values, any mean values are acceptable, are close to the true population's mean. Okay, so this is what we call as confidence interval. So when you say interval, it is a range. So there are two scores involved. Okay, so it is a CI, or the confidence interval is the range of values defined by the confidence level in which population parameter is estimated to fall. Okay, so what is the range? So when you say sample, you take one sample, you get 2, and the second sample you get 3. So what is the range of possible values that is close to the true population's CGPA? Okay, and it is also called the margin of error. So let's look at, okay, let's say that the blue box is the population. Okay, so this entire population consists of 5 individuals labeled as A, B, C, D, and E, and each of them has a score of 1, and then B has 2, C has 3, 4, D has 4, E has 5. Okay, so these are the, let's say, score from the statistics quiz. Okay, so this is 5 individuals, so entire population. So let's say that we want to extract 5 different samples from this population. Okay, so in each of the sample, you should have 2 participants. Okay, so sample 1 could be A and C. So I need to get, in the sample, need to have 2 participants. So if I randomly pick them, it can be A and C. The sample 2 can be C and E. Sample 3 can be BC. Sample D can be DA, and sample 5 can be EC. Okay, so if you notice, sample 2 and sample 5 is pretty much the same participants, but it's just the way that you have drawn your sample. Okay, so this is just an example. You can have different possible combinations of 2 participants. Okay, so we know that participant A scored 1 for their midterm. Participant C scored 3. So what is the mean of theirs for this sample? It will be 1 plus 3, 1 plus 3, A and C, divide by 2. So what do you get? It will be 4 divided by 2. So you will get 2. So sample 2 will be C and E. So C is 3, E is 5. So 3 plus 5 is 8, divided by 2, you get 4. So you see, when you are taking a mean from a sample from these population, you get different combinations and the mean of them will vary. So what is actually the population mean? So the population mean is you add all the scores from the participant in your population and divide them. So it is 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. Divide by 5. So the mean, the population mean is 3. So if you notice, the first sample was 2. The second one is 4. So they are actually not true population mean. The true population mean is 3, but they are close enough. So that is what we say. That is the reason why we say we need to estimate the confidence interval. So we would like to say that, okay, the population mean could be somewhere around this range. Okay, in reality you will not able to identify the population mean because you don't have the entire population. All you have is only the sample. So in this case, just for the illustration purpose, I have given you the population mean. Okay, so the idea is, the purpose of this illustration is to give you an idea that when you are sampling from a population, you have a tendency to get values that are not exact to your population's values, population's mean. So what we need to do is we have to find a range of possible values that is close to the population. So how do we do that? Firstly, we have to look at what we have in hand. What is the information that we have? So what do we have? We have sample size. Okay, the number of participants are being informed. Whether you have 25 or you have 30 participants. So you have the number of participants. Next is the mean for the particular sample is being given. Okay, and then followed by the standard deviation of the sample. These are information that we get from the sample. Next is we have to, with this information, next is we have to determine, this is crucial, we have to determine the level of confidence that the sample mean will fall close to the population mean. So you have to determine based on your sampling, how confident are you that this sample is representative of the population, and the value that you will get will fall within this the range that you get will the value that you get, the sample mean, will be close to the population mean. So how confident are you? If you have a good sample, you'll be very confident. If you have a good representative of sample, you'll be very confident. Okay, so how do you actually translate this confidence? You translate it into percentages. Okay, so I'm 95% confident that sample mean falls with a particular range. Okay, so it can also be 99%. Okay, it cannot be 100%. Then if 100%, it becomes point estimate. So there is a room for error. So we have to remember that, because you are getting information from people, there is tendency to get errors. People will not, it is impossible to get exact values, because when you involve people, there are a lot of factors that could influence a person's responses. So you have to give room for error. So 95% meaning you are giving 5% for error. 95% I'm confident, but there are about like 5%, like 5 out of 100 samples could give me a value that is outside or far from the mean. That is the tendency, right? So if you take if you take all the high achievers, all the dean list students only in your sample, what happens to your CGPA? Your CGPA will be, your average CGPA for UPSI will be very high. It will be maybe 4 flat. So, but you have to remember that they are not just the representative of the university. There are still poor achievement students. There are still moderate achievement students. Thus, dean list students are just very few. So what happens to that? It does not represent your population. So you have a wrong conclusion or wrong estimates about the population. So you need to be you can usually people choose in social sciences about 95% confidence. So when you with the 95% and with your sample size, with your mean and standard deviation, we can actually use the standard normal distribution to compute our confidence interval, the range of scores. Okay, um, how and why can we use it? Why can we use the standard normal distribution? Because there is a proven theorem called central limit theorem. So what does this central limit theorem says? Okay, so it says that when we collect samples, when you collect randomly repeatedly of the samples, and when you increase the number of participants, what happens is your distribution will resemble like a bell curve. Okay, so a lot of people will be in the middle. The extreme cases will be less at the towards the tail part. Okay, so remember the bell curve, the middle will be heavier or thicker, and towards the tails of the both sides you have less space or less cases. So what happens is when you collect more samples, more responses, your distribution of values or distribution of mean will resemble as a bell curve. Okay, and so since it is becoming like a bell curve, so it will form like a bell curve. You can actually use a similar ruler, which is a standard normal distribution ruler, to make comparison, to find the confidence interval. Okay, does it ring you a bell? Have you seen these things before? If something just clicked in your mind, if you feel like this is something that you have done before, yes, you are correct. We did this last week with standard normal distribution table. What did we do? We are given a range of values. We say that what is the percentage of getting values between 20 and 30 given a mean and the standard deviation, and then you calculate what is the percentage. Now what happens is you are given the percentage, which is 95%, and then asked to calculate the range. So we are actually working the opposite direction. Last time was given the value, given the confidence interval, and asked to calculate the percentages. Now the percentage is given, we are asked to calculate the X values or the confidence values. So how do you compute confidence interval? Definitely using a formula. So what is the formula? So CI, confidence interval, is equivalent to mu, mean of the sample, plus minus Z multiplied by the standard error of the mean. Okay, so remember, now we are not looking at the individual scores, we are using the mean. Okay, so mean is a summary statistics from the sample. Okay, so mean, that is why we are using standard error of the mean. Standard error of the mean is same as standard deviation of the scores. We want to see how far is each mean from the each mean from the average of all the means. Okay, because from the sample, what do we calculate? We calculate the mean, the averages from every sample. So what is the grand mean? What is the overall mean of the mean? What is the average of all the means that you get? Okay, now first is estimate the z-score for the designated percent of confidence from the table. Okay, so if you have 95% confident, so what is the z-score that is associated to it? Okay, same like the other day when you calculated. Okay, when I say like, okay, 5% will be in the top value, so you find the criteria or the cut score. So same applies here. For 95%, what is the cut score? Okay, that will be obtained from the table. Next is you calculate the standard error using the formula given. So standard error is the standard deviation of that particular score, of the particular means, okay, divided by sample size. Okay, sample size divided by the square root of n, the sample size. Then use those information to calculate the confidence interval. See, when you say confidence interval, there are two scores involved because it is a range. So there is a minimum and there is a maximum. So that is why in confidence interval formula above, you find there is a plus minus. So for minimum, so confidence interval is mu minus z multiplied by the standard error of the mean. For the maximum, the upper bound, upper limits, it will be mu plus z multiplied by the standard error. So the last step will be we have to interpret it. So we can say that 95%, it is 95% confident that the actual mean of the population will fall between this particular range. So let's look at an example. Let's say that you are given a mu of 10, okay, a mean of 10 with a standard deviation of 5 for sample size of 25. And we say that you are 95% confident about this sample, okay. And first step is estimate the z-score. So for 95% of confidence, the z-score will be 1.96. Okay, the question is, how do you get 1.96? Okay, if you notice the distribution, okay, 95% with the range, there is unshaded area of what is left of 100%. 100 minus 95%, there is 5%. So 5% you have to divide into 2 because you have positive and negative sides. So when you divide 5 by 2, you get 2.5% for each side. So 2.5, you convert it to proportion, becomes 0.0250. So that is the tail area. So this tail area is 0.0250 and the cut score is 1.96. Okay, so whenever that you are doing a calculation, when you say 95% with a z-score, it will always be 1.96. Okay, so it can also be, question can also be like given 99% of confidence. So what will be the z-score? Okay, so you have to know how to calculate it. Next is calculate the standard error using the formula given. So with the standard deviation of 5, sample size of 25, what will be the standard error? 5 divided by the square root of 25. So you get 1. Step 3 is calculate the confidence interval. So substitute all this information. So mu 10 minus 1.96, that is the z, multiplied by 1, which is the standard error of the mean. So the minimum will be 8.04 and the maximum will be 11.96. So it is 95% confident the actual mean of the population is between 8.04 and 11.96. So you are getting a range. Rather than saying that the population mean is 10, you are actually giving them a range of values. So any values between this is considered close to the population, the exact or the true population mean. So you can actually use this estimation to infer about the population. Hope it was clear. Thank you.